Hi there, greetings from IOO Labs, a reliable partner for organizations in all their custom software and data analytic needs. In today's video, we are going to talk about the key advantages of using an automated data pipeline in data analytics over manual extraction, transformation, and analysis using queries and Excel macros. A data pipeline is a systematic and automatic process for efficient and reliable ingestion of data from different sources after verification, transformation, and summarizing of data to find different patterns, and finally storage of data in a data warehouse or data lake. As organizations are building applications with smaller code bases via microservices, the efficient movement of data between these microservices becomes more critical, where data pipeline plays a major role. Also, a well organized data pipeline supports various big data projects like data visualization, exploratory data analysis, and machine learning. Let's go over the key benefits of a robust data pipeline one by one. It implements real time processing of data based on an automated schedule, as opposed to user led processing that can cause delays. It applies transformations and business rules consistently, whereas manual analysis may introduce inconsistencies and errors, especially in complex tasks. It enhances data quality through automated validation and cleansing processes. These processes ensure that the data is accurate, complete, and consistent, which is essential for reliable analytics and decision making. It frees up time for expensive resources such as a data engineer and an analyst for more strategic tasks. It facilitates holistic data view by simplifying data movement between various sources and destinations, which otherwise can be challenging and daunting. It democratizes data access for broader organizations by supporting data visualization that are centrally accessible, self serving, intuitive, and narrate a powerful data story.
This diagram explains an ELT process, or in other words, extraction, loading, and transformation. It is different from a ETL process, or extraction, transformation, and loading. In the sense, here extraction and loading are done together and transformation added on later. On the contrary, an ETL process, extraction, transformation, and loading are sequential.
Here's an example of a data pipeline workflow, which we will see in detail soon. Let us first understand all the tools that are used in our data pipeline building. In our example, we have a tool called Airbyte for extraction and loading process. Airbyte will help us ingest data from multiple sources, which also includes a development kit for ingesting from APIs. But for the demo purposes, we will be ingesting data from an Excel sheet. Airbyte is hosted on a Docker container and thus can be deployed on any operating system or server. The data that we'll be ingesting is pushed from an Excel sheet to Postgres server. Once loaded in a Postgres server, we would use PySpark and Apache Spark API to cleanse, enrich, and transform data and push it back to a Postgres server. Some examples of such transformations are replacing of null data, adding new columns to data table to link them with other tables, or adding one hot encoding for feeding into ML algorithms. Post transformations, the data can be visualized using Power BI, a very effective visualization tool from Microsoft. It allows to create data summaries and insights very effectively with relative ease. Additionally, it also provides in multiple mechanisms to create interactive and visually appealing dashboards. These dashboards can be hosted on the cloud, refreshed in an automated manner, and also be integrated with any website or web application. Let's try out this workflow in action now. As you can observe on my screen, I have imported Google spreadsheets of an attendance record in an organization as provided to me in their native format. Here we can observe the 28 columns for the month of February. These records contain the employee's name, the department the employee works for, along with the days he was present. It is also documented whether he had an overtime on a particular day. This row right here shows us the entry time, presumably 8 am of the employee, while this row shows his exit time. These are around 1500 records spanning over 16,000 rows, as each record probably takes 10 rows. Let me take you over to Airbyte, the data ingestion tool connecting spreadsheets to Postgres database. Here's my connection. As you can see, it has detected the workbook's name. Under the job history, we can check out the recent run and its logs. Here's how many MBs of data were ingested to our Postgres database. Under the schema, we can check out the different columns Airbyte has detected. Under the settings, we can configure the periodicity of the ingestion sync from manual to scheduled, ranging from an hour to 24 as per the organization's need. Let's run the sync right now for the sake of this video. We have successfully transferred the data from the source to destination database. Let's check out a newly created table in Postgres using pgadmin, a tool for managing our Postgres database. Here's our raw table, identical to the source spreadsheet. As you can see, these are the day 1 to day 28 columns. Let's head over to PySpark for efficient transformation of data for further big data analysis. Here I have imported the necessary libraries and initialized the Spark session. These are the necessary parameters for JDBC connection to a Postgres database. Over here I have opened the table in a PySpark data frame. It is similar to our original spreadsheet. We can drop the unnecessary Airbyte meta columns. I have filtered the database, taking only the useful rows into the filtered data frame. We have provided a different transformation code to convert the horizontally added records to vertical entries. Over here I have used a hash list to further extract useful information. Here's the final data frame that shows us the name of the employee, the shift date, the in time and the out time. It also shows us the work hours, which are calculated from the difference of preceding columns. Let's view this transform table in our database. We can see it is identical to the transform data frame in PySpark. Let's head over to Power BI for data analysis. This dashboard is designed to provide a comprehensive view of employees' attendance and work patterns, making it easier to identify trends and make informed decisions. These are the 4 summaries on the employees' distribution: the departmental analysis, the shift analysis, and the day-wise analysis. These are the original fields pulled from Postgres transformation table. In order to plot these graphs in a meaningful format, we had to create additional dimensions. The tiering of the employee into less than 4, 4 to 5, so on hours helped creating this graph. The binning of the present percentage by less than 30%, 30 to 50%, and greater than 90% formed this heat map. The tiering of the overtime hours to less than 10 hours, 10 to 20 hours, on until greater than 60 hours formed this graph. Just from the original date format, we were able to recognize the day-wise distribution of employees' attendance, the employees' average work hours, and overtime distribution in Power BI. Finally, these insights demonstrate the power of a well-constructed data pipeline in Power BI dashboards in uncovering critical issues and opportunities within the organization. By leveraging these tools, we can make more informed, data-driven decisions that drive efficiency and productivity. As we saw in the demo, when we built a data pipeline, we can ingest data real time based on an automated schedule and thus save the time in querying exercises and data movement. Additionally, we can also cleanse, validate, enrich, and transform data in an automated manner, thereby saving the time and effort required prepping data for analysis. All this time saved up frees critical resources for strategic projects like prescriptive analysis and machine learning. Furthermore, with the usage of powerful visualization tool, the data analysis can be served to a large number of people through interactive, self-serving dashboards, thereby creating a data-centric culture within the organization. Automated pipeline can handle the additional load without compromising on the performance, ensuring that your analytical capabilities keep in pace with your business growth. Compare this against manual data analysis, which requires lot of time for preparing data, which is often archaic and has a slower turnaround time from data to insight. It is error prone and requires heavy resource commitment for data preparation and analysis. The data accessibility within the organization is limited as it requires a data analyst to explain. During analysis, there are lots of repetitive tasks which are redundant and save time if we automate them. So the direction is pretty clear. Organizations need to invest in building automated data pipelines to be able to use data broadly, efficiently, and in a sophisticated manner. This will pave way for building a data-centric culture within the organization and ushering a digital transformation. Let's look at some frequently asked questions that people might have about data pipeline building. What kind of business rules and transformations can be applied in a data pipeline? In a data pipeline, a wide range of business rules and transformations can be applied, including data filtering, aggregation, normalization, enrichment, and validation. For example, you can filter out irrelevant data, aggregate sales data by region or product, normalize date formats, enrich customer data with demographic information, and validate transactional data for accuracy. These rules and transformations are typically defined using a combination of coding and configuration tools, ensuring that they are applied consistently and reliably across all data. How do data pipelines enhance data quality? Data pipelines enhance data quality through automated validation and cleansing processes. These include checking for missing values, duplicates, and anomalies, data as well as standardizing formats and correcting errors. For instance, a data pipeline can automatically identify and remove duplicate customer records or correct misspelled city names. By automating these tasks, data pipelines ensure that the data is clean, consistent, and ready for accurate analysis, leading to better business insights and decisions. What are some challenges of implementing data pipelines and how can they be addressed? Some challenges of implementing data pipelines include handling large volumes of data, ensuring data security, and maintaining data quality. Well, this is where IO Lab shines and comes into picture. We help you build and implement robust data pipeline solutions. Our team consists of meticulously organized individuals with years of experience in data engineering and analysis. We provide tailored solutions that address your specific challenges, leveraging the latest technologies and best practices to ensure efficient, secure, and high quality data processing. By partnering with IO Labs, you can focus on leveraging data insights to drive business growth, while we handle the complexities of your data infrastructure. Hope you found this video informative and useful. If you or your organization are looking for building custom data pipeline solutions, then please get in touch with us and together we can define new possibilities in data analytics. Please visit our website www.iolabs.com for further information on all our services. Thank you for watching. Have a great day.